All right. Good afternoon, folks. This is Eric Gila, Director of System Operation and Market Design at ESIG. Welcome, everyone, to this ESIG and GPST special webinar. For those of you not familiar with ESIG, we are a membership-based nonprofit organization providing objective information, resources, and networking opportunities in support of clean energy and energy systems integration decisions. We do this through workshops, tutorials, webinars such as this one, blogs, and working groups and task force activities, producing various reports and other technical resource materials. And for those of you who are members, thank you for your support. It makes these free webinars possible for folks to join and all the other work that we do. So thank you to those. And if you have interest, please reach out to us if you are not yet a member. Our workshops and monthly webinars are open to everyone. So feel free to register anytime on the ESIG website, www.esig.energy. You can also find us on LinkedIn, YouTube, Facebook, and Twitter. Yeah, just a few logistical matters before we get started with today's webcast. First, all participants will be muted for the duration of the webinar to avoid any unnecessary distractions. For the Q&A, we will use the Slido platform. We'll, I think, post that in the chat and ask that you ask your questions through that Slido platform at slido.com rather than using the chat on the WebEx platform. You enter in ESIG. Let me just make sure I see. Yeah, enter in ESIG 23 as the event code, and Brooke will correct me if I got that one wrong on the chat, but I think that's the code for today. The instructions will be written on the chat there. So you can ask a question. You can do thumbs up button to help prioritize the questions that you think are good questions to ask our speakers today. And just a quick reminder for everyone to please be respectful with your questions and also to post questions for the speakers rather than personal statements or opinions. Those are better use of the time for the speakers. So plan to save about 10 to 15 minutes for Q&A at the end and then wrap it up at the top of the hour. And we'll send an email link with recording and material afterward to ESIG distribution lists and those that are participating today. So we'll get in just a quick introduction to the topic and to our speakers. So distribution energy resources or distributed energy resources can include any number of generation load or storage technologies connected to the distribution grid that can support the distribution grid, or often in aggregation can support the bulk power system as well. They do this by providing a number of important distribution or transmission services, and they're typically incentivized through compensation from the local distribution utility, the independent system operator, wholesale markets, or through reduction to their customer bills. Sometimes these services can be combined, but oftentimes they can conflict each other when they're being provided simultaneously. So we'll hear a bit about more of this in this presentation. Here's some of the history and latest updates of both wholesale markets and distribution level services, and yes, all the different implications around having more of these types of resources providing both of these services at simultaneously or at different times and during different conditions. So we have two colleagues of mine who I'm happy to have here today who will present from EPRI to share their thoughts on the subject of DERs providing grid services. Tanguy Hubert is part of EPRI's DER integration team, and Waleed Aslam, part of EPRI's transmission operations and planning group. So for all the folks that participated in ESIG's DER working group or its system operations and market design working group, you should find today's presentation especially relevant. So a short reminder again to use Slido with the code ESIG23. Without any further ado, let's go ahead and get started. So I'll turn it over to I think Tanguy might be kicking us off. So over to you, Tanguy.
Thanks. And I am going to share my screen here. And hopefully you guys can see my screen okay.
Yep.
Perfect. Thanks, Eric, and thank you for the opportunity to join this session here. My name is Tanguy Hubert. I am part of EPRI's DER integration group. As we get started here, we thought it would be good to level set on what exactly do we mean when we talk about DER provided grid services. We do refer here, and that will be our context for this presentation, to the ability that certain DERs have to adjust their power imports and or exports. And they do this in support of system operations. That's really what we're going to mean in the context of this presentation when we talk about grid services. So DERs have flexibility, and they use that flexibility to support system operations. Not to be confused with the flexibility that certain network elements might have. Think about circuit reconfiguration, for example. That's a different kind of flexibility. So really, in the context of our presentation today, we want to focus on DER flexibility and specifically how to capture or harness that flexibility using grid services. Grid services is the term we use in North America. In Europe, the term flexibility services is used quite a bit. Really, in the context of our discussion, those are the same thing. And we will talk a little bit about Europe at some point. That's why we have this note here. And then finally, those grid services are provided voluntarily by DERs for some sort of financial compensation and in response to system needs in time and or specific location. We can distinguish between distribution services, that are services provided by DERs to the distribution utility, distribution system operator, and then wholesale or bulk services that are provided to the wholesale market operator. That's for level setting here as we get started on the discussion on what exactly do we mean by DER provided grid services. Importantly, it's also good to recognize that at the end of the day, we really care about DER flexibility, and grid services is only one of multiple possible mechanisms to harness DER flexibility. I usually call this the 3 doors to DER flexibility. We can capture DER flexibility via connection agreements, and specifically non-firm capacity agreements, also called flexible interconnection, flexible connection, flexible energization. There are a number of terms there that are in use. But the point is that with those connection agreements, we try to lock in DER flexibility upfront. That's one way to do it. Grid services are another way, and that's going to be our focus today. So with grid services, we procure DER flexibility through various mechanisms, most of the time competitive mechanisms. And then finally, time varying prices are another way to harness flexibility, where we encourage DER assets to be flexible in response to prices. So again, even though we're going to focus today on grid services, important to recognize that they are just one of multiple possible mechanisms to harness DER flexibility. And from a grid standpoint, DER flexibility is really what we are after. Those are potential mechanisms to capture that, but DER flexibility is really the overarching goal. So today we're going through this grid services door, and we're going to start with a segment on wholesale market services. I'm going to have my EPRI colleague, Waleed Aslam, take us through that section.
Thanks, Tanguy. Hi, everyone. My name is Waleed Aslam. I'm part of EPRI's market operations and design team. So basically, now that we've established that DARs can provide services at the wholesale and distribution level, we'll be kicking off with the wholesale market services. And for today, we'll be focused, at least in this bit, we'll be focusing more on the US-based ISOs, RTOs, and how DARs can participate within these markets. But we do note that despite some of the design differences, similar kind of participation avenues exist in other regions, such as in Europe and UK markets. So with that, starting off in terms of like DAR participation in the ISOs, RTOs is primarily driven by a bunch of FERC regulation that has come across over the years. So back in 2008 is when Order 719 came out, and it kind of facilitated the participation of demand response resources in the wholesale markets. So with that order, the ISOs were kind of required to treat these demand response resources comparably to any other conventional generation resource. There were some questions around the implementation and around performance and compensation that were subsequently addressed in Order 745, which came out in 2011. And along the same lines, then in 2018 is when Order 841 came out, and it established the set of rules for market participation of storage resources. It basically allowed storage to participate in capacity, energy, and ancillary service markets, and established different kind of operating processes around that. For example, how storage could, what sort of parameters it would require to participate in these markets, and how it could manage its state of charge, for instance. And then in 2020 is when Order 2222 came out, and it did essentially the same thing, but for DER aggregations. And I mean, the DER aggregations can comprise of variable energy resources such as solar photovoltaics, but they may also comprise of either demand response resources or storage resources. So there is a fair bit of overlap between Order 22 and some of the previous orders which corresponded to demand response and storage resources. But having said that, it does not replace any of those previous orders, but in fact adds to them in some ways. And the compliance, as far as compliance is concerned, all the previous orders have already been complied with by the different regions, but Order 2222's compliance is still ongoing, and of the ISOs, only California ISO is the one which is currently implemented it so far. So next slide, please. So now that we have established that, so what basically all these orders did is that they kind of facilitated the creation of different participation models and ISOs, some of which were tailored for DER resources. So for example, in California ISO, which is already implemented for 2222, some of the models that are typically aimed at DER resources would include models like DER provider model, which is aimed at aggregations. Then if you look in the table and like in rows 2, 3 through 5, what you'll say is basically the different types of models that a demand response resource can pick and choose to participate. Essentially, PDR model is when they just want to curtail load shift resource model, as opposed to that is when they could also increase their load in response to certain signals. And similarly, the reliability demand response is essentially the same thing, but they get triggered under reliability conditions. So then for the storage and hybrid type of resources can use some of the other models, such as limited energy storage models, or generic non-generating resource models. Essentially, the difference between these different models is the kind of constraints that they may come with. Some of these models enforce, for example, state of charge limits, while others enforce some kind of energy limit over a daily period, and others may come with no such constraints. So depending upon so each resource is not kind of mandated to follow one particular model. So for example, a resource type such as storage can very well pick and choose a DAR aggregation model as well, as long as it satisfies the underlying requirements for that model, and it's okay with giving up some features or accepting some additional features that may come with that model. So typically, the different considerations that a resource owner may have to go through when picking and choosing a certain participation model would be things like, the underlying technology of that resource. Different models may have different size limits, both minimum and maximum size limits in some cases. So that may also govern the choice. And one other thing is the eligible services. Not all models are allowed to provide different kinds of services. So for example, some demand response models may not be eligible to provide regulation reserves. And if, for example, a resource wants to provide them, then it'll have to pick and choose a different type of model in that case. There could be different interconnection requirements for some of these models as well as different metering and telemetry requirements. And similarly, there could be different ways, slightly different ways in how some of these models get compensated, or some of their offers get mitigated in some cases. So that may also govern, this choice. And as far as the DER aggregation itself is concerned, there could be choices along the lines of, if it's a homogeneous DER aggregation, which means that it contains only one type of underlying individual resources, versus heterogeneous, for example, it could contain demand response, storage, as well as other variable energy resource types. Because in some of these homogeneous models, there are sometimes some constraints or some rules which prevent participation under certain circumstances. So next slide, please. So now that we've seen that there are different models for a resource to choose from, let's see how a particular model may compare across different ISOs. So in this case, we're looking at the DER aggregation model, which was facilitated by FERC Order 2222, and we're kind of comparing across New York ISO and California ISO in this table. So in terms of the different services that can be provided through these models, essentially in both these ISOs, this model can provide all types of services. In California ISO, since there is no capacity market, so that's why there's no capacity service here, but they can be used to cater to the resource adequacy requirements. One big kind of differentiating factor between California ISO and some of the other regions has been in terms of the locational requirements that this DER aggregation model has. So for example, in New York ISO, the aggregation that can participate through this model has to be located at a single transmission pricing node, whereas in California ISO, they can span multiple nodes as well. And this is still an ongoing kind of matter of compliance in different other regions as well. So this may, since California ISO has already complied with it, so multiple transmission pricing nodes is okay with FERC, but single transmission pricing node may get changed, as this is the subject of some compliance proceeding in some of the other regions as well. And there are obviously then some requirements in terms of the metering and telemetry requirements are much stricter in California ISO, potentially based on the fact that they do allow multiple transmission pricing nodes. So, and similarly, there are differences in terms of the maximum and sizes of individual DARs, as well as the overall aggregation size that can exist in these two regions as well, with California ISO limiting the size of an aggregation as well. And lastly, one other difference between these two regions is in terms of how they compensate the demand response resources that are present in an aggregation. So for example, in New York ISO, the net benefits test, which is a test for measuring the performance and subsequently the compensation of demand response resources, is applied to only the demand response component of an aggregation versus in California, where it is applied to both the entire aggregation itself and not just the demand response component. So next slide, please. So now that we've seen that the different models through which DERs can participate in the market, let's see where the current participation status is at for different types of DERs. So on this slide, we have on the top the demand response related figures, and on the bottom we have storage penetration related figures. So if you look at the DER numbers in different regions, especially here in the top right graph, what you'll see is that in some regions the DR capacity is as high as 10% of the peak load in the system. And so what that means is that, and it has been, while these numbers are slightly dated back from 22 and 23, the overall trend that has been is that the DR participation has been growing in different regions, and they are providing a significant portion of the load. But one important component is that only around 15 to 20% of this capacity is coming from behind the meter or smaller resources. Most of it is, again, coming from larger resources. And same kind of story goes with storage penetration as well, especially, for example, in so the storage graphs here are only for the front of the meter resources. And what you see is that, for example, the numbers for PJM, for example, even though it has like around 400 megawatt of front of the meter storage integration, only around 65 megawatt or like around 10 to 15% of that capacity is existing behind the meter. So, I mean, what I'm trying to say is that even though the DR participation is growing in these regions, most of it is located at the front of the meter rather than behind the meter. So next slide, please. So so now moving on to the DR aggregation bit, I mean, similar kind of narrative can be seen there as well. Part of it is because a lot of the regions are currently complying with FERC 2222 and have not yet fully, realized the different projects that could participate in the market under this model. Most of the currently operating projects are only providing services at the distribution level, whereas only with some kind of future plans to participate in the wholesale market. For example, even though ERCOT does not fall under FERC jurisdiction, but this is some place where we could find some relevant numbers, was like in the ERCOT program, there are only 3 qualified resources which are currently providing services totaling up to 15 megawatts of energy and 8 megawatt each of different types of ancillary services. And other regions have very similar kind of participation numbers. So then you may ask that why is there so limited participation from DR aggregations? And part of the reason for that is because the DERs that want to participate in the wholesale market are faced with very long interconnection process, so they may choose some other avenue of investment, or may just simply switch to providing retail services or participate in retail programs, which may actually be offering better incentives to them. And secondly, one of the things is that they do have a lot of strict and stringent telemetry and coordination requirements, which could equal a lot of investment on their part as well. So that is something which could discourage them to participate in wholesale markets again. And one other important bit is that when DER aggregation is providing services to both wholesale market and the distribution level programs, it is the distribution reliability services that typically take precedence over wholesale services. So in case of, so they may end up losing on some of the revenue if they're participating in both, or they may be operationally constrained because of those kind of constraints. And so they may again be tempted to participate more in retail programs. And similarly, from a ISO perspective, the DAR aggregation program, I mean, it's the one reason why the compliance is ongoing is because it is competing with a lot of other initiatives and projects in terms of priorities for the ISOs. So having said that, I think I'll pass it back to Tanguy, who will take us through distribution services.
Thanks, Waleed. So we have covered here this past few slides, wholesale services that DERs can provide either individually or aggregated. We're now moving to distribution services, which is the other category of services that DERs can provide. And as we get started, we need to clarify right away what exactly is the difference between this concept of distribution services and the other sister concept of NWAs. I like this Venn diagram here to explain a little bit how those concepts relate. Non-wired alternatives can be implemented using DERs, but they can also be relying on other kind of technologies. So NWAs are essentially ways to eliminate or at least defer traditional or conventional distribution system upgrades. That's really what NWA is all about. And again, that can be using DER technologies, but that can also be using other kind of technologies. When we are using DER technologies, we can essentially package the needs. There are the distribution needs that are being addressed by the NWA solution into service products, very similar to what is done at the wholesale market level. So when that is the case, the NWA and the distribution services that we are packaging are really the same thing. That's number 2 here. We can also recognize that distribution services, while they might be used to defer traditional system upgrades at the distribution level, they can also be used to provide other sort of economic services. So NWAs that rely on DER technologies can be decomposed and packaged into distribution services, but some distribution services can also exist outside of this notion of NWAs deferring traditional system upgrades at the distribution level. So I think that's an important distinction here to make as we get started on distribution services. Now, distribution services is a very new concept. We just talked about wholesale services. They are very well established at the bulk system level with service products that we understand very well. At the distribution level, distribution services are very new. We do not have yet a suite of distribution service products that are common across multiple regions, well-defined, etc., etc. So we are in many cases still at the level of understanding what are the attributes, what are the parameters that we need to use to define those distribution service products. And very often those attributes, they map those 3 categories that I have on the slide here: location, where do we have a distribution need, timing, when do we have this need, how fast do we need a response from the service provider, for how long, how often, and then the magnitude. What is it that we need? Is it real power? Is it active power? And how much are we looking to get? So those common attribute categories, and within each category, there is a range of parameters we can use. That's what utilities are using to essentially develop these new distribution service products that they want to put out there for third-party service providers to provide distribution services. And those products are developed in a way that aims to be agnostic of a number of things: what technology is being used on the DER side, whether it is a behind the meter or front of the meter resource, whether the resource is owned by the utility or the third party, whether it's a standalone resource or an aggregation, what's the readiness level? Are we going to be providing that service with a new resource that we're going to connect, or existing resources? Point is, we're trying to develop those distribution service products in a way that is agnostic of all those parameters. Now, there has been a number of utilities that have been going through this exercise of developing service products. As an example, from the UK market, and I believe a recent ESIG webcast went into those examples here that I have on the screen. The UK utilities have defined 4 different distribution service products: sustain, secure, dynamic, and restore. Those are the names of the products. And those products are intending to address either needs in planned distribution conditions or unplanned distribution conditions. And then for each product, there is a different timeline in terms of the needs that we want to address, whether it's a need identified to occur in n-0 condition or n-1 condition. And then obviously the utility's willingness to pay for those service products depends on what would be done otherwise if those distribution services were not provided. So for example, for the sustain product, which aims to address needs, recurring needs that occur in normal conditions, typically the willingness to pay for that service product is defined by the cost of the upgrades that would be required otherwise. So there we see that depending on the location, depending on exactly what the upgrade would be, the willingness to pay for that service product may vary from one location to the other. Another example for maybe the dynamic product that is used to address unplanned conditions. There, maybe the willingness to pay has to do with what would be the cost of the unplanned outage if we did not have access to that service, or maybe the cost of wheeling some mobile generation, again, if we did not have access to that service. So this is a very important notion, the fact that those distribution services are meant to maybe achieve a certain level of performance at a lower cost from the perspective of the distribution utility. So understanding that willingness to pay is very important, especially when we present those new service opportunities to the potential providers. So point of this slide here, number of utilities have been starting to develop those distribution service products, still very early stage compared to what is being done at the wholesale level, where we have decades of experience developing wholesale service products. Now, what's the current status in terms of distribution services? So on the Europe side of things, there has been a lot of research funds put into essentially demonstrating this concept of distribution services over the past decade. The UK, I was showing a slide on the UK a moment ago. The UK has really been the leader in that space, and pretty much every single distribution utility in the UK at this point is required as part of their planning process to systematically evaluate service-based alternatives to traditional distribution upgrades, and then publish essentially the service opportunities for potential providers to submit bids and provide those services. Another point to note is in the UK, they really started with strong focus on service products that do not require capacity reservation. So it's essentially products that intend to address contingencies. So customers are signed up, they are in the system, they have the capacity to provide those services during contingency events, but they are not required to. So during a contingency, they are called. If they're available, they can provide support. If they are not available, the utility would default to whatever measures they implement during a contingency. So this is maybe a lower risk approach in terms of getting started on distribution services. In addition to the UK, other regions very active in that space in Europe, Nordic countries, the Netherlands. There are a lot of distribution constraints in the Netherlands everywhere, so they are very, very active in that space. Germany, France have also conducted regular tenders for distribution services this past few years. So lots of activity in Europe. However, we have to note here that the actual volumes today remain limited. Yes, there's a lot of research on this, demos, integrating this into standard planning processes and such, but still volumes remain limited. On the US side, the initial focus has been a little bit different. So work on this started probably, I would say 5 years ago. And initially the focus was very much on longer term contracts that could only be met deploying new resources. So think very much of all the dialogue around NWAs and replacing substation upgrades and such, and having third parties do that. So wrapping those needs into distribution services. To the contrary, in Europe, the focus has been on using existing resources for needs identified perhaps more in the short term. So different focus. In terms of regions, New York and California were definitely early movers in the US. It's when it comes to California, it's good to know that it was one of the really early programs trying to implement distribution services in a systematic manner at scale. This is known as the DIDF program. But the program is currently effectively paused because of a number of challenges over the years, despite multiple tentatives to adjust and improve the program. There are, limited techno-economic opportunities for distribution services. I think that's what we have been observing this past few years. There are also other limitations, such as interconnection delays that really prevent from getting resources connected that could provide those services. And then there has been perhaps also a bit of a shift in the mindset. 5 years ago, we were very much thinking about deferring upgrades. With EV growth now and a lot of load growth, we are now thinking more about adding more capacity, not less capacity. So there is also this notion of, do we really want to not be building capacity at a time where we have more EVs connecting? And again, that view that was very prevalent 5 years ago is now reassessed in light of all the new EV connections. There are also, the reality that there are multiple initiatives, so to speak, or multiple layers that are competing in terms of getting the attention of the DER owners. So whether we are talking about DER programs, different connection products, flexible interconnection products, this concept of grid services versus now bulk services in the wake of Order 2222. So DER customers have a lot of options. I guess that's what I'm getting at. And so perhaps because of that, there has been a little bit less attention from their part on distribution services and understanding this as an opportunity for them to pursue. In conclusion, similar to what we see in Europe, in the US, as it stands today, distribution services, we are only really seeing a very limited volume of active providers. In terms of combining wholesale services and distribution services. Value stacking is intending to do just that. It's the notion that in theory, we can enable a given DER asset to stack revenues by providing multiple services at the same time, whether that's in a single domain or across multiple domains, meaning providing distribution services and bulk system services. That has always been thought as a way to improve the financial viability of DER projects if they are stacking revenues from multiple sources. The notion there is that ideally it would make it easier to finance those projects. And those services can be provided either simultaneously or sequentially, maybe an hour for one service, another hour for another service. That's again the theory. All stakeholders agree that if we were to pursue this, a minimum requirement is to make sure that this does not compromise service performance. So that's a theory. The practice is that in most areas, this remains something that is being discussed by stakeholders. It's a nice concept. Some regions have a framework in place. So in New York, there is the concept of dual participation that is implemented where wholesale participants providing distribution services have to submit an offer in ISO that align with their distribution level dispatch. So it is being done. Primarily, this is being done by standalone battery storage projects. But the reality is that at this time, there are very few assets that are actively engaged in value stacking strategies. One question around value stacking is who gets priority. There is a sense that we don't want to be in a situation where there are two conflicting services that are being called at the same time, and the resource cannot provide both. So at a high level, again, we expect providers to always deliver on their service commitments. So before committing to an additional service, providers should verify that pursuing an additional service is not going to compromise the performance when it comes to the services they are already committed to provide. So the question is, who is responsible for that? Who is responsible for verifying that there is compatibility between this set of services the resource wants to provide, whether this is done by the providers, whether this is done by the entities requesting the services, utilities, ISOs. In most regions, this is still very much of an open question. So now I want to maybe take 5 minutes here to walk you through some of the ongoing developments, and then we'll have time for questions. So we've talked about what wholesale and distribution services are all about, and this notion of value stacking when we try to have a single resource provide multiple services. Ongoing developments. So we need to work on standardizing the interactions between the utility and the aggregators, and that's especially relevant for distribution services. Right now, those interactions are basically custom interactions. We have to reinvent the wheel anytime a given vendor or a given aggregator is working with a given utility. So that's extremely slow, extremely costly. So that's one area of ongoing developments. At EPRI, we have an initiative called Flexit, where we are partnering with a number of distribution utilities to try to speed up this process, understand what exactly are the interactions that are the most common, the most time-consuming, costly, and what is it that we need to be doing to speed up and standardize those interactions in a way where an aggregator could now go talk to multiple utilities and they don't have to reinvent the wheel every single time. So standardizing interactions between service providers and service requesting entities is one area of ongoing developments. Access costs, realizing that especially for resources wanting to provide wholesale services, realizing yes, wholesale services are a potential way to generate revenues, but accessing wholesale markets is not free. And that's perhaps what sometimes aggregators or even individual DER owners realize a bit late. There are those categories of upfront cost, meaning those costs have to be taken into account before the DERs can even provide wholesale services, and ongoing costs to essentially maintain the ability to provide services, whether they have to do with interconnecting the resource if it's a new resource, or paying for distribution delivery charges during the lifetime of the project. That's at the distribution level. At the wholesale level, getting the resource recognized as a participant, making sure that it has all the proper metering and telemetry, and also posting the appropriate collateral or credit requirements. This comes at a cost. Maintaining communications during the lifetime of the resource with the ISO, that's another source of cost. And then there are all the entities that essentially help facilitate DER participation. And that's especially relevant for maybe individual DER owners who are not expert in this, so they need help. They need to work with contractors, an aggregator, maybe market intermediaries. So this also comes at a cost. So understanding what those costs are and those cost categories are, and understanding whether those are barriers preventing DERs from greater participation in wholesale markets. This is very much of an ongoing industry activity. Another area has to do with metering complexities, especially for beyond the meter resources. Whether we are using a dedicated meter, which is the standard way at the transmission level, or whether we want to use sub-meters, or this notion of shared meter, which is very much a demand response concept. Those have pros and cons. Dedicated meter obviously is easier, but by definition, beyond the meter DERs, they don't have their own meter. They are behind a utility meter along with other resources. So we can use sub-meters, but then when we start using sub-meters, there needs to be a reconciliation process with the end user meter, the utility meter. And most AMI systems are not ready for that. They need significant upgrades to conduct those calculations. So in the meantime, we can use the concept of shared meter, which again is something that is done in the demand response space, but then we have to work with baselines, generating baselines, and that adds complexities. And also this approach is perhaps not sufficient for certain grid services. It might be enough to verify performance for some grid services, but some other grid services may require a dedicated meter, either a standalone meter or a sub-meter. So those metering complexities, very much of an ongoing topic of work for the industry in terms of enabling grid services from DERs. And maybe one last here, settlement. How do we settle the amount of energy that is being exchanged between the DER and the grid? There are different approaches for that. So typically for distribution connected resources, the current approach is the distribution utility is the one that is responsible for settlement per the retail tariff. Whereas at the wholesale level, it is the ISO that is responsible for settling for energy. So what do we want to do now that we have DER assets providing wholesale services? So we're kind of like crossing, connecting across the two grid domains, so to speak. So we can stick to the status quo and have the utility settling per the retail tariff, but that presents a number of challenges, whether we look at potential energy imbalances at the T&D interface, or the simple fact that current practices at the ISO level is that participants are settled by the ISO. So we now have to think about potential double counting issues that we have to address. Similarly, if we want to go with the approach where the ISO is the one settling, that also presents challenges, because typically retail tariffs are used to cover some distribution costs. So now we need to find a way to cover those differently. So settlement complexities, I don't have time here to go through the details, but that's another area of ongoing work when it comes to enabling more and more DERs, either standalone or aggregated, to provide grid services. I want to bring us back to this notion here that even though we have talked a lot during this presentation about grid services, we don't want to lose sight of the big picture. At the end of the day, what we are after here is harnessing DER flexibility. So recognizing that DER assets have this flexibility to adjust the timing and magnitude of the amount of energy they exchange with the grid. And there are different ways to do that. We can work through that through the connection requirements. We can use flexible connection agreements to lock in flexibility up front. We can certainly use pay-for-performance grid services, whether at the distribution level or at the wholesale level, or we can use prices. So those are different methods to try to harness that DER flexibility. I think it's very important to not lose sight of the fact that that's the end goal. I'll pause here and perhaps we can go through a couple of questions.
Great. Thanks so much, Tanguy and Waleed. There are quite a few questions up there on Slido. I don't think we'll be able to go through all of them, but we can hit a few of these, and then we'll try to get some responses to those that we didn't get and send out. Really quick clarification. This might have been Waleed. You had a chart, and you had, I think it was demand response on the chart, and then you were talking about, so I'm pretty sure it's just DERs. This question's asking demand response front of the meters, but I think it was just DERs, front of the meter versus behind the meter DERs.
Yeah, so yeah, I think basically the classification there was like something which is more visible to the ISO itself, like things that are connected at the transmission level directly versus smaller scale ones which may be connecting from the distribution level. Yes, yeah.
Okay, question maybe for you again, Waleed. For aggregations participating in the wholesale markets, can you share any other standardized rules or protocols that that essentially make sure that the operation is within distribution limits? Maybe talking about some of the override procedures or things like that.
Yeah, sure. In general, I think one thing that we've seen is that like whenever there is kind of a tiebreaker that needs to go on, like for example, if a DER aggregation is asked by the wholesale operator to do one thing versus the utility to do something else, then it's the utility that has to take precedence, because the idea is that the DER is at the end of the day located in the distribution network, and the reliability there is much more important in that sense. So that's one thing. I think one other, just linking to this one question, I think one thing was that someone had asked about if there are some exceptions to the interconnection queue within DER aggregations or like some of those models. So I think the quick answer to that is yes. Some of the demand response models, they do not have as strict of interconnection requirements or may not have to go through all the interconnection queues. But then those kind of models do not allow you to provide some sort of services. So for example, some ancillary services may not be provided through those models. So those are the like trade-offs that a participating resource may have to, weigh before choosing one or the other of those models.
Yeah, next question here. Actually, it's a good one. I'm not sure if either of you know this, but I actually think Mike probably knows the answer to his own question. Since the UK, Tanguy is sharing a lot about what the UK has done, and seemingly one of the more advanced countries in terms of these DER participation rules. Is there anything they've done to the rate-based model for the utilities that's unique compared to others that can provide, that removes a financial disincentive for maybe enabling this type of participation?
Yeah, there's been a couple of things done there. Two different directions. One has to do with being rewarded for performance. So as a utility, if you're able to essentially be innovative and find a way to operate your system and generate efficiency, find a way to operate your system in a way that generates efficiencies, you can keep some of that difference in cost in your pocket. So that has been one approach. The other is this concept of TOTEX. So instead of making a distinction between CapEx and OpEx when it comes to cost recovery, merge those two categories into a single category, TOTEX, and then enable cost recovery on that. So said differently, sometimes the issue is that when the utility has to decide between investing in wires and the alternative, which would be procuring a service-based solution, sometimes they can get cost recovery on the CapEx option, but they cannot do that on the service-based option. So making sure that there's no difference between those two options from a cost recovery standpoint is one way to remove any bias, so to speak, towards the traditional CapEx option.
If I can follow up, Tanguy, any thoughts about how this performance-based model can be applied, in the U.S. and also is it done outside of UK that you're aware of? Just to share with our listeners.
Yeah, there are a couple of I think countries looking into that, and even frankly in the U.S., for example, I believe in California. I mentioned briefly the DIDF program. I think there that the IOUs have been able, for the few projects that go through there, they are able to get cost recovery on that. So I don't know necessarily that even though it is a potential barrier, the difference of treatment between CapEx and service-based options, I don't know necessarily that this has been the main barrier. I think the main barrier has been more related to realizing that there are maybe not that, or maybe not as many opportunities for service-based solutions as we thought initially, in terms of opportunities that are both technically feasible and also feasible from an economic standpoint. And then when they are, there is also the realization that market volumes are very limited right now. So it's not like there is a line of service providers that are waiting to provide the services. It's still very new at the distribution level. And finally, for service opportunities that require the deployment of new resources, there is the reality that getting a new resource connected takes a lot of time. And so those delays can effectively be a barrier to pursue a service-based solution. Or maybe the timing just doesn't work with the distribution need, and we'll have to default to doing the transformer upgrade or upgrading the line.
Great, thanks. I think perhaps this is the last question, just kind of, and we'll get to some of these other ones, so I am skipping around a little bit, but on value stacking, Tanguy, I wonder if you can share in just a couple minutes on what types of wholesale distribution services are mutually exclusive, and yeah, anything you can share on yeah, the impacts that they might have on each other.
Yeah, it's really it really depends on the availability and the capabilities of the resource, right? So if we take a little simple example, you know, battery storage, there is power capacity, energy capacity, or duration, right? So those are the two main parameters. That storage could potentially provide two different services even simultaneously if we were to segment the power and energy capacity of that system into two virtual systems. So at that point, we can pretty much provide whatever services we want with those two separate virtual systems. Now, if that same storage system was to, so to speak, overcommit itself and promise its full capacity to two different services, and that somehow those two different services would be activated at the same time and asking for contradictory dispatch signals, that's where we would run into issues. So it has to do with understanding the service requirements and potentially incompatibilities there between different service products, but it also has to do with understanding what are the capabilities of the resource and to what extent potentially we can segment that resource into virtual sub-resources, so to speak, that could provide different services.
Great, thanks. We're about 2 minutes over, so just want to thank Tanguy and Waleed again. We didn't get to a lot of these questions. We'll get them posted. We'll get together and respond to a few more of these. We'll post that with the recording and the material and share it with everybody. Thanks again, everyone participating, ESIG members, for your support, making these webcasts available. Look forward to seeing you all at the next webcast, or maybe at our upcoming fall technical workshop in Philadelphia, October 27th through the 29th. Hope to see many of you there. Lots of DER related topics that we should have included there. If you're interested in participating in the DER working group, reach out to anyone at ESIG or myself. And yeah, further information can be found on esig.energy under events, and also in our newsletters and emails. Feel free to attend those. Waleed, Tanguy, thanks again for presenting this. And yeah, thank you all for participating. I hope everyone has a good rest of your afternoon.